welcome to my office today. I'm in Sun Valley, Idaho. It's pretty nice out, not gonna lie to you. But we're gonna be learning today about the neurology of empathy. And so, first off, we're gonna look at the anatomy. So, you have cognitive empathy and affective empathy. Cognitive is when you take someone else's perspective, and affective is when you literally feel what they
Continue.
Affective is when you literally feel what they feel. So to walk you through the process, it starts with the occipital cortex, where when you take in someone else getting hurt, and then you think to yourself, do I know them? Your brain will separate that out, because if you know them, you'll respond more instantly usually. And then you have the mirror neurons, which pretty much copy and paste your feeling that you've had when you've experienced pain to the situation that you're in currently. And so that's when the superior temporal sulcus, the inferior parietal lobe, and the inferior frontal gyrus work together.
Brain?
Yes, that's brain.
Wow, that's funny.
And you think, I have felt that, and then that must hurt is when the insula comes in. So then your anterior cingulate cortex sends downward information to your thalamus and brainstem saying you can feel that pain sometimes, and then it goes sideways to your insula where you get awareness and emotion, and then up to your prefrontal cortex that helps you make a decision. So at that point you're ready to go and act, because you saw someone get hurt, and so you either cringe or go and help them, or your heart rate goes up and maybe you're ready to go sue. So, the ability to experience affective empathy has a lot to do with the anterior cingulate cortex, and this helps us to feel the emotional aspect of someone's pain. And in a research study done with mice, like this little mouse, they were looking at their friend who was getting zapped on the leg, and while the two mice were being tested, it was activating these pathways where neurons in the brain responsible for empathetic behavior were showing a link to emotional response. And so, okay, so there's also an aspect to empathy that is social. And so a human fMRI study studied 29 women who had either their spouse, someone that they were in a romantic relationship with, or a stranger get a pain stimulus. And so they saw them get their arm burned, and that they actually saw their arm get burned. But anyways, they saw that they were getting in a painful situation, and it actually happened where the people that they were in a romantic relationship with, they felt more for them than a stranger who's experiencing the same pain.
That is true.
And so the scans also showed increased blood flow in the insula, amygdala, and the TPJ, and that was in the people who were watching their loved one get hurt.
In Ghana, we call that blood is thicker than water, because our people we don't know, we feel like it's water that goes through them, but people that we care about, we feel like it's blood that goes through them.
Facts.
So it makes sense.
Okay, so then the last study was one that was done by it was 39 people, and half of them had migraines chronically and the other half didn't. And they were studying to see if someone who experiences chronic pain experiences empathy and pain empathy differently. And so participants viewed 4 different types of images while they were in the fMRI, and it was a picture of someone who was like cutting their finger, and then it was a neutral picture, and then it was a picture of someone who was like cringing, and then a neutral picture. And they found that chronic pain can enhance neural responses to types of observed pain, because the migraine patients had heightened activation in the inferior frontal gyrus than those without the migraines. In conclusion, empathy is influenced by both social context, like seeing a loved one in pain, and individual differences. These studies show that empathy is not a fixed response. It's shaped by biology, relationships, and personal experience. Understanding these mechanisms of the brain give a clear picture of how empathy may be enhanced and limited to limit pain for medications in the future. The mouse study shows that the ACC is responsible for linking the observed distress and emotion, and the people with the chronic migraines show how amplified a certain response can be to a type of pain. These studies dispel neuromyths that empathy isn't changeable. It has many factors and it can be treatable and possibly changeable. Hopefully it will help us have more medicine for pain in the future.
Like Tanalo?